Welcome to IOTA Virtual Learning. I am Shitu. In this video, we explore the topic of probability, a key concept in WAEC, JAMB, and NECO exams. We look at experimental and theoretical probability, how to handle independent and mutual exclusive events, and interpret situations involving and or in probability. So let's dive right in. So I have this question 1 here on the screen. The question says, when a fed coin is tossed once, what is the probability of getting a tail? We have the option 0, 1, 0.5, then 2. So I have this question here with you. If you can solve it, kindly pause the video, do it yourself, and join us solving together. Okay. So now what I would like to tell you, they say a fair coin. Look at this, a fair coin here. This a fair coin, they means here, a fair coin has two sides. That is, when you have a coin has two sides, and that says this side we have head or tail. So these are the two sides we have. We have head or tail. This head is H and this tail, okay, is T. All right, so probability of an event, that is, what is the probability of getting a tail? So the probability of an event is the probability of an event. PR means probability, is the formula here. So now, according to what we are given here, we want to look for the probability of getting a tail. So the probability of getting a tail is going to be like the favorable outcome we have. Favorable outcome, okay, is what is tail, because out of these two that we have so when a fair coin is tossed one times, so the only time we see tail is what is just one. So this is what we said, this one is what, this one is one times. Then the total possible outcome here, the total, okay, possible outcome, we have it to be what? We have it to be tail and what? Tail and head. Tail and head. And their number, we have what? We have the number to be 2. So now what we are actually looking for, or what we're going to get now, is that so to get what is the probability of getting a tail? So to get a tail, so the probability of having a tail is now going to be 1, which is the favorable outcome, divided by total possible outcome, which is 2. So we are going to be having our answer to be 1/2. And 1/2 is same thing as 0.5 in decimal. So we have the option C to be the solution to the problem. Question 2. A card is drawn at random from a standard pack of 52 playing cards. What is the probability of picking a king? So now I want you to solve this problem here. Pause the video, do it yourself, then come back and let's solve this together. Now they make mention of a standard pack here. This standard pack has 4 kings. The standard pack has what? Has 4 kings. Okay, so 1 for each what? 1 for each suit. So now the total cards is given to what? Is 52. So now the question asks us that what is the probability of picking a king? So the probability of picking a king, so you know that our favorable outcomes is going to be 4 because we have 4 kings in a standard pack of cards. Alright, so the next thing we're going to do, we're now going to have what? So we're going to have P, which is the probability of having king. The probability of having king is now going to be, what is our favorable? Our favorable is what? Is here, which is what? Our favorable outcome is what? Is 4, which is here. So we're going to write 4 divided by the total outcome we have is this, which is what? Which is 52. Okay, so we're going to have what? We're going to have 52 here. So now the next thing we're going to do is to reduce 4 over 52 into the simplest form. 4 divided by 4 here. Let's say divided by 4 and this divided by 4. So you see that we're going to have 1 over. So 52 divided by 4 will give us 13. Understood? So from here, we have the solution to be, our answer is what? Is this, which is what? Which is A. 1 over 13 is a solution to the problem. This is question 3. The question states 2 coins are tossed. What is the probability of getting at least one head? So we have the options here. These are the options. So we have A to be 1 over 4, B 1 over 2, C 3 over 4, and D equals 1. So now here, 2 coins are tossed. What is the probability of getting? So what I have here, I call this coin, that is 3. So now this is where we're going to get our possible, the total possible outcomes. So when you toss 2 coins, or when 2 coins are tossed. So now here, so this first toast, first, and this is the second toast. All right. So now from here, now if you want to get the possible outcome here, you are going to pick this by this. That will be HH. Okay. So we're going to have this will be HH. So the second one we're going to have this, which is HT. So we have possible. We have H what? HT. Then here the next one is this one, which is TH. Okay, so we're going to have TH. Then the last one is this, which is TT. So we're going to have TT. So in total, if you count all of this, we're going to have 4. This is the 4 total possible outcomes. But the question asks us to find what is the probability of getting at least one head. So when you look at each of what we have there, okay, if you look at all of these, you can see that you are now going to be picking the one that has what? That has at least one head. So you can see that it's only this one down here that doesn't have what? That doesn't have any head at all. So therefore, all the other threes are, they are having what? They are having heads. All right. So at least one of them. So we are going to pick all of those. So that's going to be, we're now going to have what? We're going to have the possible outcome, a possible outcome, possible outcomes is going to be, we have HH, okay, comma, we have HT, then comma, we have TH. So in total we have this to be what? We have this to be 3. So now to get it now, so the probability of getting what? Of getting at least one head, at least one head, okay, is now going to be equals, what is the number? The number of the possible outcome is 3. We have 3 here, divided by the total number of possible outcome here is 4. So we're going to put 4 here. So we have 3 over 4 to be the solution. This is our answer. Then let's check the option. So we can see that we have the option C. So option C is the what is the solution, our correct answer. Thank you. So we get into the next question. Question 4. A bag contains 3 red and 2 blue balls. One ball is drawn at random, replaced, and then another ball is drawn. What is the probability of drawing 2 red balls? We have these options down here. If you can solve this, kindly pause this video, do it yourself, and join us solving this together. All right. So this is with replacement. So if you read the question, so we can see something here where they mention replaced. When a ball is being drawn, then we replace it back, then we draw another one. Okay, so what is the probability of drawing two? So now what I want you to take note here is this is with replacement, and so the probability stays the same for each draw. The probability stays, the same for each draw whenever we have what the replacement, if it is replacement. All right, so what we're going to do here is that we are going to look for the probability of red first, because they said 3 red and 2 blue balls, they are in the bag, and what is the probability of drawing 2 red balls? So we're going to look at the probability. Okay, probability of probability probability of drawing probability of drawing red first, of drawing red. Let's say we have red first, so the probability is going to be 3 over 5, because the red ball is 3 here, 3, and the total. Okay, sorry, let's first look at the total. So what's the total? The total is what? The total ball is 3 plus 2, and that will give us what? We're going to have 5. So we have 5 balls. Okay, now so when we now draw the, we have the total number of the red balls to be 3, so therefore it's going to be 3 over what? 3 over 5. 3 over 5. That's then the probability of the second ball drawn, okay, which is still red. So we're going to have second red second. Okay, this red second is still going to be the same thing, because I told you, if it is with replacement, okay, so the the probability stayed the same for each draw. So we're still going to have 3 over 3 over 5. Understood? So now, because what is the probability of drawing 2 red balls? So we are now going to have it to be uh probability of probability of red and red, okay, and what? And red in the second time. So that's going to be 3 over 5. The word and here means what? Means multiplication, so we need to put it there. So therefore we're going to have what? We're going to have 3 over 5 multiplied by 3 over 5. So when you do the multiplication, so you're going to have 3 times 3, we have 9. Okay, then 5 times 5, we have what? We have 25. So we can't actually reduce this further, so which shows that that's our last step. So now looking at the option here, we can see that we have 9 over, we have this to be 9 over 25. So you have option B to be the what? You have option B to be the solution. Question number 5. In a box, there are 6 red, 4 blue, and 5 green balls. One ball is drawn at random. What is the probability that it is either red or green? So when they say either red or green, so red or green means red or green. This red or green means we add the probabilities together. So we are going to add the probabilities together. So that's the word. That's the word. red or green, we are going to add the probability together. So I want you to write it down somewhere. We are going to write, we are going to know red or green. The or that is there is what is addition. All right. Okay, so let's move on. So when we have 6 red balls, we have 4 blues, and we have 5 greens. So what we need to do here is that we need to first find the total balls. The total, you see that we have 6 plus 4, then plus 5. So in total, so we're going to have what? We're going to have 15. Definitely, we have 15 balls in total. Now, the next thing we're going to do is that what is the probability of what? Of drawing a red ball. So probability of drawing a red ball, probability of red. So the probability of red is going to be, what is red? We have 6. That will be 6 all over what? Over 15. And what is the probability of what? Of drawing green? Because what we are concerned with is what is red and green. The probability of drawing green is what is green? 5. We have 5 over what? 5 over 15. Okay, 5 over 15. So now the next thing we're going to do is that what is now the probability? Okay, what's the probability of probability? It is either probability. It is either what? Either red or what? Or green. So we are going to have it to be equals. So what is the probability of red? The probability of red is 6 over 15 according to what we have here. Then plus the or that is here is what making us to be adding it together. If it is and, remember in our previous example, so I said and is multiplication, but here all will be what? Will be addition. Okay, then for the probability of green, so we're going to have 5 over what? 5 over 15. 5 over 15. So now adding this together, we're going to have 6 plus 5 over what? Over 15. Then we're going to have 6 plus 5, that is 11 over what? Over 15. So now we have 11 over 15 to be the solution. All right, so when you check the options here, so you're going to see that we have option A. So option A is the correct answer to the problem. All right. Question number 6. 2 fair dice are thrown. What is the probability of getting a total of 7? A total of what? Of 7. All right. We have the options here. So I would like you to pause the video, do it yourself, then come back and join us solving this together. So we have the options right here. So now let's see how we can do this. 2 fair die are thrown. What is the probability of getting a total of 7? So we are having 2 dice here. So now the first of all, when 2 of them are thrown, understand we have 2 dice. If 2 dice are thrown, okay, the favorable outcome, the total or possible outcome we can have, the possible outcomes is going to be 6 times 6, which is equals to 36. The reason is that we know that in a dice has how many faces? Has 6 faces. Do you understand? So now we have 6 coming from one dice, and we have another 6 coming from the second dice. So multiplying 6 and 6 together, so we're going to have 36 to be the total possible outcomes. So whenever you are thrown 2 dice, okay, we have 36. Now that's the first thing we need to know, the possible outcome we can have. That's the first thing we need to know. Now the second thing we need to know is that we now want to know, the second thing is that what is the probability of getting a total of 7? What's the probability of getting a total of 7? So the favorable outcome, so this is going to be, look at this. If you throw, you can either have 1 on one face, okay, and have what, and have 6 in other case, in other face. Then also we can have 6 comma 1. You can have another one. If you pick 2, the other place, the other side can be what, the other side can also be 5, because we are looking for the total of 7. Then we can also have 5 comma what, 5 comma 2. Another one we can have, if you pick 3, you can have 3 comma what, 3 comma 4, and what, and 4 comma 3. So which, now let's count. We have 1 2 3 4 5 6. So therefore we have the total possible, I mean the favorable outcomes, to be what, 6. So we are going to be having 6 what, 6 of them that will be giving a total of what, of 7. So these are the possible outcomes we can have if 2 fair dice are thrown. So now the next thing we are going to do is to find the probability of getting what, probability of having total of what, total of 7, total of what, of 7. So to get the total of 7, that's going to be the possible outcome, I mean the favorable outcome. The favorable outcome is what, is 6, what we have here. Okay, so we have what, we have the favorable outcome is what, is 6. We're going to be having 6 divided by the possible outcome is what, is 36. So 6 divided by 36, so we're going to have 1 over 6 if you reduce it. All right, so we have 1 over 6 to be the solution to the problem. Now let's check our options and see whether we have 1 over 6 there. So you can see that from here we have what, we have the B to be what, 1 over 6. That is, the B is the solution to the problem. Sorry, this one is 36. It's 36, not 1 over 36t. So it's 1 over 36. All right. Thank you. Question 7. A bag contains 4 red and 6 blue balls. One is picked and not replaced. A second is picked. What is the probability that both are red? Now, there's something I would like you to take note here. They said, and not what? Not replaced. So that is telling us that when the first one is picked, it wasn't replaced. Then they now pick another one. So what is the probability that the both balls picked are what, are red? So those are the things we need to know. All right, so it's very simple. What we need to do, let's first find the total balls. The total balls is going to be 4 plus 6. Then we are going to have what, 10 balls altogether. Okay, both red and blue. So we have what, we have 10 balls. Now the second is picked. What is the probability? Now if you want to know the first pick, the first pick, the first picked, okay, is going to be, which is red. This is going to be, what is the red? We have 4. That will be 4 over what, 4 over 10. Okay, we have 4 over 10. That's the probability when you picked the ball, I mean the first, if it is red. Now the second picked too. The second picked is also what, is also red. So therefore here, what will happen here is that the number of what, the number of the red ball will be reduced to 3, and the total number also will be reduced to 9, because the first one was picked without replacement. So therefore, whenever you have that, the number, the favorable outcome and the possible outcome will be what, will be adjusted. Okay, so we are going to have 3 over 9. So now, to find the probability that both are red, both are what? Are red. Both are red is now going to be 4 over 10, then multiply by 3 over what? 3 over 9. So now from there, we're going to have 4 over 9, that is 4 times 3, divided by 10 times 9. Then we're going to have 12 times 3 will be 12 over what? 90. So now if you try to reduce this one to the lowest form, okay, when you divide this by 6, 12 divided by 6 here, I'm going to have 2, and 90 divided by 6 here, we're going to be what? 15. So therefore, we have our final answer to be 2 over what? 2 over 15. Okay, so 2 over 15 is the solution to the problem. So let's see what we have from the options. So we can see we have option A to be the what? Option A to be the solution. And thank you so much. All right, well done for sticking through to the end. Now you have mastered the key tricks for solving WAEC, NECO, and JAMB probability questions. So remember, probability is always about favorable outcomes over total possible outcomes. Stay sharp, practice regularly, and you will ace your exams with confidence. Don't forget to like, share, and subscribe to IOTA Virtual Learning. Thank you for watching. Bye.